Hello, my name is Jalaluddin bin Jamil and I am from CEE 2423C and my matrix number is 2021834542. Today I would like to discuss the report of Lab 1 Armed Assembly Language Programming, Data Transfer, Data Processing and Addressing Modes. And the objective today is to write assembly language program for the ARM microcontroller using data transfer, data processing, instruction and addressing modes. Also to execute the programs using an ARM kill editor, assembler or simulator. Okay, let's move to the question number 1 here is to write a program that will store 0x30 into R0. Copy the content of R0 into R5 and then save data 0x45085612 into memory location 0x40000030. Execute the program and explain the differences in the results. Also, discuss the addressing modes of each instruction used. Okay, let's go to the lab number 1. Okay, so this is my coding and we build. Okay, so as you can see, there is no error. So we run the program. Okay, firstly, we set up the memory window with 0x40000030 here. Okay, it's already set here. And then we click here. And then we click here. Okay, we use move command here with the value of 0x30 into R0 as you can see here. Okay, the next line, click here. And then as you can see R5 with the value of 0x000030. Seems like R0 is because the question is to copy the content of R0 into R5. And we also use the move command. And then we click here for the next step. Okay, and then we use the LDR command with the value of 0x40000030 into R1 here. And also same for the next step. We use the LDR command with the value 0x457855612 into the R2. Okay, here. And then we store the content of R2 into R1 here. As you can see, this is the final result 12567840 in the memory of here. Okay, so that's it for the last line. And so for the discussion of the here, for the first line here is we use here is immediate addressing mode. And for the second line here, we use register addressing mode. And the third here is immediate addressing mode. And the here number fourth line is also same, immediate addressing mode. And the last line here we use indirect addressing. So that's all for lab number 1. We move to the lab number 2. Okay, so now let's move to the question number 2. Write and execute a program that will add 0x20FE F690, 0x FE123089, and 0x34589710, and save the sum in register R7. Record the change in CPSR as well. Okay, let's go. Okay, so this is my coding. We build. As you can see, there is no error here. And we just can execute the program. Okay, click here, then here. Okay, as you can see the content of R0 here, 0x20FEF690 in the window register value here, R0. And then we click the next line, same as R2 here, LDR here, with the content of 0xFE123089 here. And next, also same with R3 here, 0x34589710 in the R3. Okay, so we use ADDS here because we need to see the CPSR value. And then for the next step here, click here, we add R0 and R2, content of R2 into the R4. And here is the answer here. If you want to see the CPSR here, add here, just you can see just the four main here, NZCV. As you can see here in the R4 content here, N equal to 0 because the MSB here is equal number 1. If the number is more than 7, so N equal to 1. If less than 7, it equals to 0. And the Z also equal to 0 because if there is a value, it will be, if there is value, so as you can see there's a value equal to 0. If there is no value, it will become 1. And also C, we got 1. V, carry here, pointer carry, so it becomes 0. So we move to the next line. As you can see, R5 here is NZCV all 0 and 0 because there is no value in MSB that more than 7, and Z is there is value, so it becomes 0, and C also 0 and V also 0. And then for the next line, we store we use move command with the content of R5 into the R7 here. Okay, that's all for the lab number 2. So let's go to the lab number 3. Okay, let's move to the question number 3. Write a program that will store 0x2936 FEDA in R8 and then perform the following instruction on the content of that register 4 times. Comment on your result. Number 1, arithmetic shift right, logical shift left, and rotate right. Okay, let's move to the time. Okay, so this is my coding here. And then we build. As you can see, there is no error. And then you can just execute the program. Okay, click here, here, here. Okay. Okay, as you can see here, okay, as you can see here in R8 here is 2936 FEDA. We use command LDR to store the content value of 0x2936 FEDA in the register value here. Okay, and then we use the arithmetic shift right for the question number 1 4 times. It means the 4-bit, the MSB of 4-bit here, MSB here, we shift to the right 4 times. Okay. Okay, for the next step here, we click here. As you can see here, R1 is 0x02936 FED. As you can see, if we push right, it will push, and the through the carry and become 0 here. To prove the answer in R1 here, value here, we take the calculator. 2936 FEDA. Shift, make it right, 4 times. Okay, as you can see, it's same, right? 02936 FED. Okay, and then we move to the next line. Here we use LSL, logical shift left. We move forward 4 times. We shift to the left 4 times here. And you can see in R2, 0x 936 FED A0. And to prove this value, you should also use the calculator here. 2936 FEDA, logical shift left 4 times. Okay, as you can see here, it's also same here. 936 FEDA0 here, right? Okay, close it. Okay, so the next line is rotate right 4 times. Okay, we click here. Okay, as you can see, the value is A2936 FED. It's very special. It is because in the LSB here, it push to the right, and the A here, the LSB here, will transfer to the MSB here and become A2936 FED. Okay, and that's all for question number 3. I hope that explained everything that you need to know. Okay, let's move to the next question, number 4.